Good morning, everyone. We'll give folks a few more minutes to log on to the call, and then we'll go ahead and get started. Alrighty. Good morning, everyone, and welcome to our 9th and final webinar of the Florida-Friendly Landscaping Green Stormwater Infrastructure Series. Thank you all for joining us throughout the series, and we're excited to deliver our final webinar of the series. Today's webinar will be 1.5 hours long and will be recorded and available along with the rest of the series. Today, we will have a recap of key concepts from throughout the webinar series, and we will also discuss some case studies and lessons learned related to green stormwater infrastructure. Towards the end of the webinar, we will briefly recap some funding opportunities from the Department of Environmental Protection, and then we'll have an extended question and answer roundtable with all of our presenters. We will hear from experts from the University of Florida, Ferguson Waterworks, the Florida Friendly Landscaping Program, as well as the Department of Environmental Protection today. And today's speakers include Dr. Eben Bean with the University of Florida, Jessica Brusso with Ferguson Waterworks, Claire Lewis with the Florida Friendly Landscaping Program, and Nathan Jagoda with the Department of Environmental Protection. Additional information about Green Stormwater Infrastructure can be found on our Green Stormwater Infrastructure Program website, a link to which I'll provide in the chat box. To access our full webinar series, including our recorded webinars, please visit floridafriendlylandscaping.com and follow the links to training and FFL webinars, and we'll provide a link to that in the chat box as well. This webinar will not offer CEUs. I know our previous webinars did, but this one will not be eligible for CEUs. A link to GSI funding information will be in the chat, and as I mentioned, we'll also briefly cover that towards the end of today's webinar. We also recently launched our GSI inventory survey, which we use to collect information on GSI projects throughout the state, and a link to that survey will be in the chat as well. And users can submit up to 3 projects per survey session. If you have any questions for today's speakers, please submit them in the question and answer box as opposed to the chat. That way our moderators don't miss the questions. And we will answer questions during our extended Q&A today, so we won't be addressing them directly after each speaker. Rather, we'll save them for the end, and we will address them during our Q&A roundtable. And the way that will work is we'll screen the questions through the chat, and then we'll pose them to our group of presenters for their response. And with that, I will turn things over to Dr. Eben Bean to get us started.
All right, thank you very much, Nathan. Hope we're all set here. I see my screen and everything. Well, welcome everyone to our final webinar here. It has been a pleasure putting this series together and working on it with all of my colleagues from the Florida Friendly Landscaping Program, DEP, Ferguson Waterworks. We hope that you've gotten a lot out of it. And we hope that these topics have been informative. In today's session, we're going to start off by just kind of recapping some of the highlights or some of the topics, just to kind of see how things kind of pull together. And then we're going to transition into some lessons learned and have sort of that roundtable. So if you think back or you weren't able to join us for some of these talks, this will be a little bit of a refresher, or it'll give you a little bit of an overview. You know, we started off by introducing sort of the need for GSI and sort of the effect of development on our water resources and how it really shifts that water balance, particularly what happens to rainfall as it falls on the landscape, and how having different amounts of imperviousness shift that water balance. And for example, here we have at 30 to 50% imperviousness, which is similar to our residential development level of imperviousness. You might have 30% runoff. These are just kind of round numbers here. But compared to natural ground cover that might only have 10% runoff, this is about 3 times as much. So we have to mitigate that. Our conventional approach has been to kind of send that from the impervious surfaces into the street, and then into our storm drain, into our storm collection basin, and then into our stormwater ponds. And stormwater ponds were initially created for flood control and flow rate control to make sure that that flooding aspect and the erosion doesn't affect our downstream neighbors. But they've also have some water quality benefits. However, some of the nutrients, or particularly nitrogen, it's not as effective as we once thought for removing nitrogen from stormwater. And over time, we've seen that these, the impaired water bodies around the state, the areas that basically are not meeting their water quality criteria, they tend to follow the areas that are urbanized. And this is, in many ways, at least one of the contributors to this is our legacy of stormwater management, or lack thereof, and how that has led to ineffective or insufficient stormwater treatment, particularly on the water quality side, and not being able to adequately remove the pollutants that come off of our urbanized and paved areas. And so then we introduced sort of this paradigm of LID and GSI, and most of our focus has been on GSI, but these kind of go hand in hand, where low impact development in the land development process is sort of that first stage where we look at the site and what it has to offer, and look at what areas are good for preserving, which areas are good for keeping as conservation, that might actually provide greater value in its current state than if we were to develop it. And so that is sort of the point of avoiding our increase in runoff, and then minimizing the runoff. How can we minimize the production of runoff, particularly from these small storm events that happen on a regular basis? And one of the main ways is to disconnect our impervious surfaces. So if we have a downspout that goes onto the driveway, the easiest thing that any homeowner can do is to move that onto the lawn. So that at least gives it the opportunity for that runoff to infiltrate into the ground. And so this tends to help mimic and maximize sort of that pre-development hydrologic process, make the landscape function more similarly to how it was before development. So by planning this out and laying out our site in a thoughtful way, we can reduce the need for stormwater management. But there is sort of this aspect, or this element, or this quantity of stormwater that we're not going to be able to completely avoid, and that's where GSI comes in. These are stormwater practices that are intended to sort of mimic the functional processes in the landscape to infiltrate, store, and treat our stormwater runoff pretty close to where it's generated typically. And these are really good for addressing those small, frequent storm events where we weren't able to completely eliminate or avoid or minimize the stormwater runoff. Then Nathan kicked us off with kind of introducing sort of some of the resources that are available. We have grants available from DEP, 2 main ones here, 319, that's through the EPA, and then the SWAG grants that are directly through DEP. Give us a lot of information on those. If you want more information, be sure to go back and take a look at these, the recorded webinar. The link for funding is down there at the bottom. This is only 2 of the options that are actually listed on the funding webpage. But these are sort of some information for how to put in some of this stuff. Then we started looking at some of the different types of practices, and we started with sort of some innovative types of practices, in this case, tree boxes and suspended pavement systems. So with tree boxes, we're looking at how can we essentially leverage the powerhouse of the tree to take up and evapotranspirate stormwater that is generated oftentimes from an adjacent roadway, and either take that up and evapotranspirate it into the atmosphere, or allowing that to sink into the ground. These practices are exceptionally valuable for areas that are in the right-of-way and retrofits where we don't have a whole lot of space to work with, but maybe we have a long linear space that's available, and we can, through different products and technologies, we can create a lot of volume and a lot of storage volume in between sort of the roadway and sort of the pedestrian corridor there. Then we took a look at pervious surfaces or permeable pavements, however you like to use the term, and looked at sort of their functionality and the characteristics of them. There's about three main types: asphalt or porous asphalt, porous concrete, and then permeable pavers. Porous concrete, I love this image and the diagram. It's easy to identify pervious concrete because it looks like concrete, but it has the structure and texture of a Rice Krispie treat. And porous asphalt and porous concrete work very similarly in that they have interconnected void spaces that are created by removing the very fine particles from the mix of asphalt or concrete. And so the large particles are bound together, and then the void spaces that would have been filled up by that smaller aggregate, these interconnecting void spaces allow water to move through it. And though there's sort of a difference in what they look like on the top or on the surface, they're fairly similar down below as far as your profile, your choker course, and then a reservoir course, and then the soil down below. Now, we can put in under drains, and we kind of touched on that for areas where we either don't want to infiltrate, or we may not have sufficient capacity to completely infiltrate. Or if we just want to have this function as sort of a flow-through detention filtration system, particularly in those areas where we have limitations on infiltration. And you can see another example of the interlocking concrete pavers in the bottom right. And this is an example of showing that we don't need to have the entire pavement surface be permeable either. These surfaces have such a high infiltration rate through the surface that it's not really a limitation at the surface. Generally, if it's maintained on a regular basis, it's usually the volume that's in the storage zone below. And so we can typically take runoff we tend not to recommend going above 1-to-1, but absolutely not greater than 5-to-1 impervious to pervious area. And so it's a really flexible and valuable practice, particularly in areas where the land cost is high. Next, we looked at bioretention and rain gardens, and remembering that bioretention typically has some added features beyond rain gardens. We see these as a really flexible option, particularly in the right-of-way, where we can put in some treatment for stormwater that's being generated and provide sort of an aesthetic, a landscape island sort of aesthetic to it. And the profile of bioretention is an important key here, where we typically store about 9 to 12 inches of water on the surface. There's a mulch layer. And there's usually sort of a engineered media. That's one of the distinctions from rain gardens, is that media is designed to remove pollutants and be able to take up nutrients and improve the water quality. They typically have an under drain as well to help facilitate if there is a need for any to help recover that volume, that storage volume. And some of them can have sort of this upturned elbow that you see in this outlet fixture, where the pipe is extending sort of up from the bottom here. This basically is all sealed, and so the water level inside has to rise to this elevation before it overflows and actually leaves. So this creates an internal water storage, which can also help with some of the water quality benefits of permeable pavement. I'm sorry, of bioretention. Rain gardens are typically a simplified version of bioretention, kind of work very similarly. They're a depressed area in the landscape. They don't typically have sort of a stone aggregate under drain layer. They more likely to just kind of capture runoff and then infiltrate into the soil. You might improve the soil by incorporating some soil mix or compost or topsoil in that area, just to promote some better infiltration. And then it's something that can also kind of be built by a homeowner on a regular basis or on a weekend. So it doesn't require necessarily any advanced training, so to speak. So just keeping in mind that rain gardens and bioretention very similar. I typically explain that bioretention cells are designed by an engineer to meet certain specifications, whereas a homeowner can design and construct a rain garden on their home property over the weekend. Bioswales are another practice that we looked at. These are really helpful for these long, narrow corridors or adjacent to right-of-way where we want to provide some filtration of stormwater. They help to convey stormwater while also filtering the stormwater through this media, this engineered media that's in between sort of the top of the bottom of the bioswale and the underdrain here. That water has to flow through here, and this slows down the flow of stormwater through it. And then it can be basically discharged through the underdrain. And typically we can also have some infiltration into the surrounding soil as long as we have good separation from the seasonal high water table or we don't have restrictive soils. But in high flow situations, our system functions more like just a swale, and we'll typically have an overflow at the end or an outlet, sort of a riser box that might have a grate on the top of it. And so kind of bringing this into, full circle or kind of integrating it, going back to our conventional approach to stormwater management, we typically would have put the roof runoff and, driveway runoff into the street and then into the storm drain and then into the stormwater collection system. But with GSI, what we're trying to do is integrate these practices into the landscape higher up, closer to the source area, to make them part of the landscape and increase the functionality of the landscape by capturing particularly those really small regular rainfall events so that we can capture, treat, and filter that stormwater before it goes into the stormwater pond. And this way we have our water quality being treated by our GSI and not relying on necessarily our stormwater ponds to do everything for us. Stormwater ponds are designed for really large storm events for that flood control and flow rate. So this might be 10, 12-inch storm events within a day, whereas our bioretention and our GSI might be designed for a 1 or 2-inch event that may happen, maybe a few times a year, but really provides a lot of benefit to those frequent storm events that happen on a regular basis throughout the season. We also touched on with all of these practices the importance of maintenance. One of my favorite quotes is that everyone wants to build, but no one wants to maintain. And maintenance is such a part of conventional stormwater infrastructure, but as well as green stormwater infrastructure. If they're not maintained, then our system starts to not perform as it was designed. We can have blockages that are created by debris or sediment that builds up and reduces the flow. And that can cause localized flooding and cause issues to our surrounding landscape. So it's important to be on top of maintenance, schedule that. We've kind of touched on it as well that, we've just released sort of a GSI maintenance and planting manual. Plants are one of the biggest aspects when the public looks at GSI and how they evaluate whether it's healthy or not is really looking at, does it look good? Does it look healthy? And being able to identify which plants are good for a certain GSI or which types of plants are not doing well and which ones might need to be replaced can really go a long way to making that practice look more healthy and successful. And so making sure that we keep the flow of water moving into and out of these systems and keeping the health of the plants up is a way that we can help to ensure that these practices are functioning at least as well as they were designed to. We were then joined by Pete Singhofer, the designer and creator of basically the most common and popular stormwater modeling system for GSI and stormwater management in Florida, ICPR, and showed us sort of a really interesting presentation on how we can use these types of models to evaluate different types of GSI. He went through this project in Auburndale, Florida, where they had some retrofits of stormwater practices along the, I believe this is PK Avenue, and how they were able to simulate it beforehand. And they worked with Chastain Stillman and Kevin Albrecht and Drew Morrison to do this design. It was really interesting to see how they were able to route water, move from the generating impervious surfaces into rain gardens and permeable pavements, and how the different elements really function together. And so we can use these tools to evaluate and size and spec out what types of GSI need to be built. We were able to kind of look at really how these systems kind of integrate a diversity of practices, permeable pavements, underground storage, rain gardens. All of these were linked together, and we were able to see that how these systems function together. Finally, in the last webinar, we looked at sort of municipal and regulatory issues, and sort of back to this whole idea of LID and GSI. I pointed out one of the aspects is that, you know, the GSI is oftentimes kind of dictated, the rules that apply to it. A lot of it comes down from DEP and the water management districts through, and really originates from the EPA through their MPDS programs and other acronyms, but also the MS4 program. So these are municipal separate storm sewer programs, and the TMDL and BMAP programs, which address our water bodies that are not meeting their water quality criteria. The ERP programs is one that potentially could be updated if the new rule is passed by the legislature in the next new year, and that could really you know, open the door for a lot more GSI to need to be used to meet the ERP program. So we're seeing that down the road. But there's a lot that local governments can do to incentivize LID and GSI. And so we looked at sort of how codes and ordinances kind of come into play, particularly the comprehensive plans and zoning and requirements such as, you know, curb and gutter, how that can be, you know, cause or indirectly create sort of what the stormwater management approach is, or dictate what that is. We kind of went over sort of one of the tools that's available that we've developed as far as being able to audit and evaluate the local codes and sort of identify maybe some areas that could be improved, or looking at where certain weaknesses might be in the code. We're continuing to improve this, and we're actually in the process of a phase 2 that would help to suggest or identify some example codes from around the state for local governments to maybe adopt or you know, build off of for their own codes. And so that's kind of an overview and a summary of what this series has been about. We hope that has been valuable to you, and you've gotten a lot of information. If you haven't seen one of these, or I kind of touched on a topic that you weren't really familiar or didn't really recall very well, these videos are on the FFL webpage and on the GSI webpage for DEP, so you can always go back and re-watch them. So if you wanted to pick back or refresh your memory on some things. So now I'd like to transition into kind of going over a few case studies. And I'm going to cover a few, and then my collaborator, Jessica Brusso, is going to cover some as well. And we want to kind of provide some examples of where GSI has been implemented and provide sort of some in-depth examination of them. So the first project that I want to touch on is Sweetwater Preserve. And this is basically a county park area, trails and nature area. It was a stub road that was originally created in anticipation of a apartment complex that was going to go in the natural area, or the forested area. That project kind of fell through before anything could be done. But the stub road was always there, so the county basically uses it. It was used as an access point for the trails that are in this area off to the right here. The boundary of the project is shown here in the yellow outline, and this is outside of Gainesville, if you're not familiar with the project site itself. And this area directly drains to Sweetwater Branch, which is an impaired stream for nutrients in Gainesville. And if you're familiar with Sweetwater Wetland, this is upstream, just upstream of where Sweetwater Branch flows into Sweetwater Wetland. So separate project, but fairly close by. And so in about 2020, the county developed a retrofit, or a GSI retrofit plan for the site, where they wanted to basically implement a few examples of GSI on the site. So they've implemented a couple things: permeable paver parking spaces, and adding sort of a loop so that it was more convenient to access the forested area for trails, adding designated parking spots, as well as incorporating bioretention. We worked with the county to develop sort of a design that would help us to evaluate a few different design elements of the bioretention cells. There's some aspects of trying to figure out what are the best criteria or characteristics for bioretention media, that material that is down below the mulch but above the underdrain. What do those characteristics really need to be most effective for achieving water quality goals? One of the main aspects of interest here is that in Alachua County, they actually have an area of the county where it indirectly kind of requires there to be some pre-treatment before stormwater goes into an infiltration basin. So it can't just go directly into an infiltration basin or sort of a retention pond. So there has to be some pre-treatment or some other kind of treatment beforehand. So we looked at a few different types of media. One was a native soil mix to try and evaluate how well that would function, and then compare it to a fairly standard mix, which is one that was developed up in North Carolina and is used widely across the Southeast. We also wanted to look at two drainage configurations. So if you remember, we looked at one of the configurations was having an underdrain that created what's called an internal water storage zone. And so we wanted to compare that with just a typical free draining storage zone. And so here's the parking lot, and I want to kind of go over some aspects of this real quick, just some lessons learned with this one. If you notice here, again, this is an example where they didn't use permeable pavements across the entire site. They just used it in the parking stalls, and the drive path here was left to be conventional asphalt, and the pavers were left here. In the middle, if there is any runoff that does come from the permeable pavers, that is not able to be basically infiltrated from the runoff from the asphalt, that then overflows into the bioretention cell here in the middle. And you can see these openings in the curb that allows sort of that overflow to go into the bioretention area. You can also see in the lower left, this is sort of a close-up of the openings between the pavers here. Ideally, the aggregate here would be a little bit closer to the top to trap any sediments at the surface. And we might use a little bit larger aggregate. This aggregate seems to be pretty small. It's almost a coarse sand. We'd like that to be a little bit bigger. So making sure we have the right size material can go a long way to making sure it's right. It's easier to maintain. Within this area, they chose to, you can see that they put in sort of some bulrush here or some rushes planted in the system. This is fairly new after installation. So it's not like this hasn't had a lot of time to grow up. However, the lack of mulch here is probably something that I would discourage. Probably use pine straw, or if we could find a triple shredded hardwood mulch, that would be good to kind of keep some of these volunteer invasive volunteer plants or weeds that are coming in from establishing and growing up. You can also, if the plants get large enough and they're planted dense enough, that will also help to prevent that from happening. There are some other plants as well here in the bioretention along the sides as well. You can see sort of the white cap here. This is the clean out for the underdrain. Important to kind of identify that as if we're doing maintenance, to make sure that that's installed so that you can go in and identify if there's a problem with the underdrain here. It's always good to be able to inspect that whenever we're doing an inspection. One other thing that I just wanted to point out real quick is we do have an overflow on the left side. If you see sort of as you follow the rushes all the way up to the end, you'll see that there is sort of an overflow there for any excess water that's not able to infiltrate into the bioretention. This prevents ponding from backing up into the parking lot and beyond, and allows for safe bypass of that water to go into the storm drain system and discharge for the largest events into Sweetwater Branch. When we looked at the bioretention here, This was a project where we wanted to look at some different aspects, basically leveraging this demonstration project to answer some questions about the design of bioretention and what could be effective from a treatment standpoint for meeting the design the performance criteria for Alachua County. And you can see we have sort of a landscape shot in the upper right hand corner that shows, in the nearscape there, that is our overflow structure where the underdrains from the bioretention come in. You can see a little bit the inlets. I'll show another figure that helps to convey that a little bit better in a moment. We did do some monitoring here. We had some COVID delays initially with the project, but finally got it started in the spring of last year. And we've just kind of finished up about 18 months of monitoring on it. So I'll be able to kind of show you some of the performance and some of the results that we were able to find from this. Again, we were looking at sort of this comparison between just an under drain with the upturned elbow and a free draining system. So this is the upturned elbow that basically would back up the water into the cell and create this internal water storage zone. And the free draining, or to simulate free draining into the subsoil, these would be just under drains at the bottom that would not create this internal water storage. Just some photos during construction. So the way that this was designed, these pictures in the upper right shows the 4 cells when they were lined. And so we didn't have any infiltration actually occurring through these cells. You can see this is the aggregate or the stone layer. In the foreground, you can see the under drains in the back of the cells. That's where they will tie in and discharge and ultimately go through to the box in the upper right-hand corner up here. This is sort of a shot just looking down where those under drains make their way into the box. You can see sort of a close-up here of where they all kind of come in and go and basically run through the liner into the box and discharge. And so here's the sort of the layout. You can see we had 4 different 4 inlets, one for each of the basin cells, just to kind of to distribute that flow evenly across the surfaces there. Now the materials actually had different infiltration rates, so we had more infiltration through some cells than others. So the water level at the surface was the same across the cells, but we had higher rates through some cells other than others. And just to give you sort of an overview, this is sort of the aerial view. We had a little bit of runoff coming from the roadway, and so this all kind of drained over the streetscape and into basically to this point where we had a raised, basically a speed curb or speed plateau or speed table, and runoff on either side entered into storm drains on either side of the roadway. The runoff from this side basically flowed through a pipe and over to this side where everything was combined. We were measuring our inflow here. Water then went in and was distributed through those 4 inlets into each of the basins. And then we have here our under drains going into the box. Kind of look at some of the data that we had and collected. We collected, I believe, 14 or 15 storm events, looking at the water quality of the inflow and the discharge from the storm events. We look at the flow rates here. This dark line at the top is sort of our relative inflow volume that came into the basins, and then we have the flow rates for the separate configurations of the bioretention here. So our fastest flowing system was the North Carolina mixes. The top one is the free draining, and then the dashed line is the internal water storage. It had a little bit less discharge volume. And then we had the native soil with the internal water storage, and then our native soil with the free draining was the least discharging. So it had the lowest flow rate. And we think that was likely due to some of the compaction that's happening during the construction, and maybe some recommendations for how to do construction and make sure not to compact soil in certain areas versus others. When we look at nitrogen, we notice that this is a log scale. So we are typically our nitrogen concentrations that we'd like to get down to are definitely less than 1, but typically, for example, our springs and our estuaries, they have concentrations of around 0.3. So if we can get closer to that from our inflow coming in, that's good. Looking just at the median, which is a representative of the concentration, our inflow was a little over 1, so maybe about 1.5. I forget the exact concentration. But each of the practices essentially had a very similar median. And essentially all the practices generally did reduce nitrogen from the runoff to the underdrain. Now, based on the volumes of runoff being slightly different, we do have different amounts of loading coming in as well as loading coming out and draining out. So our native free draining soil had the least runoff that was accepted and infiltrated because it had lower infiltration rates, but it also had the least or lowest loading of nitrogen leaving the system as well. Some of our highest systems or highest treatment systems, the other 3 were very similar in their loading that they received, as well as the loadings that they were discharging. The best performing one, or the one that had the greatest reduction in loading, was this final one, the North Carolina mix with the internal water storage, slightly edged out sort of the native soil with the internal water storage zone. One of the other aspects to note here is that the form of nitrogen is really important in these systems, where we have organic nitrogen is probably the most difficult to completely remove. It's a little bit easier to remove ammonia, and it's a lot easier to remove nitrate. And we do see that in all of these, we see a pretty big reduction in our nitrate and ammonia from the system. And we also do see organic nitrogen reductions, but it's probably it's the dominant form in the inflow and the outflow. When it comes to phosphorus, this was actually a pretty interesting result. Each of the systems actually exported phosphorus, where our inflow concentration and loading was lower than what was coming out of the underdrain or the outlet of the systems. And this was proportional to the amount of flow that went through the underdrain of the system. The concentrations were all pretty similar in their increases. So here's our inflow, and again, this is our log scale here, where we have medians that are a couple of times the concentration of our inflow. And so we suspect that this is due because it occurred across all 4 cells. This wasn't actually tied to the native soil mix or the configuration of the underdrain, but this was likely due to the topsoil that was applied over the top of the bioretention cells. And so this is a really good point to make about inspecting and having quality control on our materials that are coming into the project, so that we're not inadvertently torpedoing or basically ruining the intended purpose or counteracting the intended purpose of the practice. So making sure that we have good quality control. And it's pretty simple to get materials tested before they go in, particularly anything that might have nutrients in it. So just want to transition to the next case study, and this is another one from our town here in Gainesville. They've done a great job with doing the city of Gainesville and Alachua County have both done a great job with piloting and putting in demonstration projects of GSI and a diversity of them. So this site is Innovation Square, if you're not familiar with it. This is within the Tumbling Creek watershed, and this has been a watershed that's been impaired for a long time. The photo here, I believe, is from 2007 or 8. It's an aerial photo, and essentially at this point, this is Tumbling Creek. This is where it first gets daylighted. Upstream is essentially a large portion of downtown Gainesville for about 20 blocks north, and let's say maybe 10 blocks wide. And it essentially all of the drainage network for Tumbling Creek, which at one point would have been a natural stream system. All of that had been over time put underground into pipes. Okay, so this is the point. This Tumbling Creek point right here is where it finally emerges from the pipes and actually is into a physical channel that it may have once been similar to. I want to point out that this area here is the former Alachua General Hospital, AGH, which is a landmark that the shutdown of this hospital opened up the opportunity to do a lot of redevelopment, as well as putting in some stormwater management within the Tumbling Creek watershed. I want to point out this pond here. This pond has been in since 1999 and was a regional stormwater facility that was put in primarily for flood control. It does have some water quality benefits for nutrient removal, but essentially taking some of the loading, runoff loading off the pressure, loading pressure off of Tumbling Creek as stormwater goes into there first. This is an aerial, a current aerial photograph or aerial photography from Google Earth of the site, and I want to highlight some of the projects that they have put in place. So notice that this area up here where the hospital was looks a lot different. This is the core of the Innovation Square, and then the overall area we might refer to that as Innovation District. They put in bioswales, which I'm going to cover each of these practices that are along 9th Street. They have a stormwater wetland as well, some bioretention area, and infiltration basins that were retrofits to help address the stormwater runoff here. So bioswales. So in this case, they essentially have a long corridor of basically bioswales where water surface runoff can come off of 9th Street and other adjacent areas, flow directly into the bioswale. They are basically divided into 2 sections of 4 cells. So you can see, for example, there are 2 cells here and here, and then 2 cells here and here. This is sort of our match line. It then would, this basically flows into this section up here, and then it flows through 2 cells and then 2 cells here before flowing into downstream into Tumbling Creek. The underdrain pipe for this system actually runs parallel and adjacent to it, actually under this section. This area here where we have the cars parked on the far side, this is the actual drive lane, whereas this is on the left-hand side is the pedestrian and bike corridor that was designed. You can notice the walking, the crosswalk here, and same for down here. They planted cypress trees as well as bulrush and a variety of vegetation here. Notice that at the under drains here, or where the pipes connect from the upstream cells where they have sort of a pedestrian crossing here, there is stone, and this is to essentially prevent any erosion from happening right at the outlet there. Just sort of a streetscape view here. You can see better the storm drain inlets here along the street that flow directly into the bioswale. And then on the far side is where the pedestrian corridor is. This provides sort of a barrier or a separation between pedestrian, high traffic pedestrian corridor, but you also do have the sidewalk right here adjacent to the street if need be. And you can see the trees are doing fairly well in these cells. I do want to talk a little bit about maintenance though, because this project hasn't been without its flaws. And we can see here that the accumulation of debris, particularly in an urban area that has a lot of traffic, it's pretty easy to identify, or it's pretty easy to see some of this material or trash and debris can accumulate in here and cause problems if it's not removed on a regular basis. We also have probably the accumulation of organic debris where maybe they cut the bulrush and left the clippings or the cuttings in there. We're getting leaves from some of the surrounding area coming into the bioswale. And during a few of these large events, we see that this material has kind of built up on top of the overflow drain and caused that to back up, causing some nuisance flooding in and around it in certain areas. So we might see, for example, in this bioswale, it might look like this on a normal day where things seem to be working just fine. There's very limited standing water. Maybe at the very end, at a very low spot, we have a spot of standing water. Seems to be working fine. Maybe we have a little bit of pine straw that is accumulated on the surface there from a previous storm event. But the cell seems fine. And a little bit of water, that's okay. We don't need to worry about a little bit of water, right? Well, this is when we have sort of these severe events where we haven't done the maintenance to address the clogging and remove the material that is causing the system to not perform and not flow as freely. So remember that the number one priority in any stormwater system is to make sure that conveyance can occur effectively. And that prevents or at least addresses the concern about nuisance flooding. So if we take a look at the stormwater wetland, I will note one thing actually moving back here. If you can kind of look in some of these cells, you'll see that some of them don't really have much vegetation above the water surface here. And that's probably something that could be addressed, where either plants that were put in are not thriving for one reason or another, and maybe we need to switch plants. And that can probably help with holding back some of this debris or organic material and preventing it from washing and getting scoured out and washing down to the outlet. The wetland here, this is adjacent or basically just across 9th Street from the very end of the bioswales, which are right here. And here is our wetland. We have basically 3 or 4 cells, depending on how you want to characterize it. These are essentially kind of half walls, or this is a full wall, and then it extends as sort of a weir or a sort of half wall across, and basically retains water back here, allowing sediment, kind of like a forebay, allowing sediment to accumulate and drop out. You can kind of see it just a little bit clearer here where that half wall is shown here. And same thing. Each cell kind of, the water gets cleaner and cleaner as it moves through. Now, this is a little bit of an innovative design where they have the walkway going across it. And this is a pedestrian area, so it's good to bring people kind of close to it and to have it integrated within the pedestrian walk area. One of the innovative aspects is that the overflow is actually down below this bridge, so you don't see it. But it's easy to maintain by accessing through a door, essentially a trap door if you know where to pull up to access the overflow there. The infiltration basin, this is another area where they have basically retrofitted it and created sort of additional storage capacity and volume control. Notice this is a walkway and path, and it has some observation points. They've done a really nice job with putting in very robust materials here, so that they don't. It's not like wood that's just going to decay. It's fairly resilient to the environment, and it's a really nice pedestrian area to walk through. And you can see sort of the layout of the system here. There's the overflow here, and it's receiving runoff from the adjacent impervious areas around the site. Now, one of the aspects that I would maybe encourage future designers to address is putting in larger plants. So this one here has, again, some of the rushes, some of the smaller plants, and until they get really robust and built and fully grown, it's very difficult to shade out or basically choke out any plants that might come in as weeds. And so it also creates sort of an issue if these plants are cut too short and are not able to be essentially maintain their full growth. When we look at bioretention, some of the bioretention cells, they've done a nice job here, as well as integrating this into the adjacent space to the roadway, particularly between the roadway and a major corridor path here as well. So the bioretention here receives runoff directly from the roadway. We've got another nice pedestrian bridge that essentially brings people and the public into closer contact with these practices. I would say that this system is lacking in mulch and could be remulched with pine straw or again, a triple shredded hardwood mulch. Particularly the type of sand that you'll see in a moment is very loose and easy to be eroded if the soil is not held in place, or if there's concentrated flows, it's easy to wash out. This is sort of an up close photo, and you can see that even the roots are able to be exposed from the plant. And we don't want to have that happen. That's going to cause the plant to dry out, and it's make it more susceptible to other factors that are not going to help it to be healthy. And so trying to put some mulch will help to stabilize this soil and reduce the risk of this occurring. Again, I kind of noted that this was sort of a space in between a bike or walking path, and they were able to utilize these really narrow spaces to incorporate sort of stormwater management into this area. So it didn't have to be a really large volume to capture, but it's able to capture and infiltrate that volume of water. And so this one does a pretty good job. But the main thing here with this site is, again, making sure that we know how to do the maintenance. If you look here, again, we have very little mulch or material that's on the surface protecting that sand that can be washed out and eroded. We see the landscaper coming in has kind of taken out all the vegetation. And it's probably good that these plants are cut back on an annual basis, but it might be, we need to figure out a way to kind of protect this soil to make sure it doesn't get washed out. We don't have these erosion issues. And it might just be in some select areas where they have concentrated flow or erosion just starting to develop. It's good to kind of address that at an early stage. And some of this material that's being removed may also be suitable for being remulched if it's cut down and as it breaks down and kind of helping to hold that soil in place. So just wanted to reiterate the importance of maintenance in these practices, whether it's for flow control or making sure we have enough plant coverage so that we are having sufficient coverage within the basin to not have erosion and sediment migration. So those are really key aspects. And just a note that we have a GSI maintenance training program and resources that are available through the DEP GSI website. And so with that, I will turn it over to my colleague, Jessica Brusso, and let her take it away from here on the next case study.
Thanks, Dr. Bean. And I just wanted to jump in and let everyone know, Clara shared a link to the GSI maintenance manual and checklist, and you could find that in the webinar chat.
Right. Thank you, Eben. Those were really informative. I enjoyed learning about those projects. So for those of you, by the way, who were at the FSA at the pre-workshop at the conference this summer, this will be a little familiar to you. So just you'll get to learn maybe some more details. But for those of you who did not attend, you guys are going to learn more detail about the Minuteman Stormwater LID and streetscape improvements. So just so you know, Cocoa Beach is on the East Coast. If you guys don't know, it's a barrier island. And you can see all this infill that was done actually with these canal roads and further out where the golf course and schools and everything are. So that was all a dredged and fill for those neighborhoods and all that land there. That was not there before. It's right on the Banana River Lagoon. If you guys also know, this was a major area, the 1950s with the boom, with the space boom. So what the goal of this project was to decrease the discharge volume to the lagoon overall, reduce the pollutant load to the lagoon, increase that superficial aquifer recharge, and also beautify, because remember, this is a streetscape project, and I'm going to show you some before and afters so you can really see how these stormwater projects can work hand in hand with beautification, and create really a more welcoming public use space. And you can see this area here. This is running from east to west is Minuteman Causeway. That's that main area or main kind of area in town. Again, that goes out to that area where the schools are and more neighborhoods, etc. Public Works is even out there too. So that's where this area is. So there's a lot of foot traffic there. The main part of the beach where people go to is also in that area. And you can see some artistic renderings of what the project was to look like, and actually really does. So turned out really close to that. Now, as far as our BMPs implemented, this was great. This is a 5-block area. And in this 5-block area alone, there are 30 rain gardens. There are 28 permeable parking spaces. So anywhere there's on-street parking, it's going to be permeable parking spaces. There's underground storage underneath the easternmost 3 blocks because there's enough room before the water table to actually have those, so you can get really good infiltration there. As you head west, we go from about 10 to 12 feet above the seasonal high groundwater table. That's by the ocean side, that we have 10 to 12 feet there. Nice sandy soils. And as we move west, that decreases and decreases to about maybe 2 feet when we're talking the other, the westernmost blocks there. So as you can see, there's not much room. That's why that site selection for that underground storage was really, really important there to make sure. Now, the sizes of the chambers actually change as well. I believe they start at about 48 inches, so they're really big chambers. And then they go down to, I think, a few feet, and then maybe even just like 1 foot on that 3rd block west. Now, as far as tree boxes, there are some tree boxes throughout. As you can see here before, actually, if you look at that center picture with the parking spaces, there's some tree boxes there before the trees were planted in them. But essentially these cutouts, 43 kind of little cutouts, if you will, little buckets for water to go into and for tree roots to absorb that water. So that's all throughout the project as well. There's also bioabsorption of activated media or bold and gold under several different BMPs as a comparison between like a rain garden with bold and gold versus a rain garden without, and even underneath some of the pavers too, and the chambers. For more in-depth on all of those BMPs, you can go to DEP's website. You can see it right there, the gsi.floridadep.gov, and then you can check out that project case study there. And you can also, just as an example, see one of the rain gardens here, and we'll go more into detail on those. But you can see that they have the pre-treatment as well as little curb cuts. And this is a really nice aerial looking to the east, and you can see that 5-block corridor there shortly after it was completed. Now, as far as funding, I like to talk about this because it, takes a village, or takes many governmental organizations and grant funding to come together to actually complete something like this. You can see the costs here. I mean, construction costs alone are $5.1 million for this 5-block area. And, it's really important to see that grant funding, especially as a municipality. You know that it's out there. You have to be able to go for it, and hopefully have some help along with that. So you can see the different sources of funding here. I do want to back up 1 second because there's a really important point here that I didn't bring up. So in this 5-block area, with all of these BMPs put together, remember that one of the main portions was to reduce all the, water going out to the lagoon, all the runoff going out to the Banana River Lagoon, and therefore reduce those pollutants as well. And it's about a 20 point, I want to say 28 acre basin coming down here. And with this project, with these 5 blocks and all those BMPs put in place, there yielded a 98.5% hydraulic efficiency. So that's really, really important. I think during the study year, it only tripped the weir at 1 time. I'm just going to run through some before and afters. Remember, again, this is a streetscape project. So not only, did we do stormwater assets, but we also did pavers walking down the streets and benches throughout, and a lot of different other things. So you can see block 1, and you can see the before and the after. It is definitely much more inviting. And of course, we increased the parking as well. Block 2. Notice a rain garden there. Way better walkability as well. A lot of crosswalks been in here, and there's signals now with those crosswalks as well. Block 3, so some older businesses. City Hall is on the left-hand side of this picture. However, City Hall is not there anymore. It's actually been raised since these pictures. But we can just see the really big difference. We have traffic calming properties as well. And the businesses have changed since the before picture. And the businesses that have gone in have actually been very thriving and expanded. And it's been really exciting to see that that go along over these years. Block 4 is just getting closer to the ocean. We're moving east. Here's a before and again an after. So way more inviting, and again, much better for the vitality of the downtown area and the businesses, of course, not to mention the stormwater benefits. And this is Block E, just looking right at the ocean. So again, far more inviting pedestrian plaza here. There is some just local traffic to the businesses that can come in and out. There's a condo back here. But for the most part, it's just pedestrians walking that way. And we did have this planter at the end. It's a little hard to tell from here, but it actually strategically planted planters that are raised on purpose, not to be rain gardens, but raised and angled to block the wind, the sand-driven, I can't talk, wind-driven sand from coming off the beach and going down. So to help block some of that. Okay, so remember, so we reduced runoff and the nutrient loads. There were utility upgrades throughout actually. So on a big project like this, it's really important to get that, talk with stakeholders, talk with other utilities, see what needs to be done. So electric with FPL was done at the same time. Underground, the water lines were changed out, sewer lines were changed out with the different utilities. So when you're undergoing such a big project, it's really important to then, again, get the stakeholder buy-in, or just have that conversation like, hey, you have anything else going in right now? Let's take advantage of the entire roadway being ripped up. But we went for, again, increased pedestrian usage and safety. It is far more walkable, far more enjoyable to sit on a bench in this area because you have this nice, increased urban canopy. The crosswalks throughout are very much more safe for the kids going to school, which remember the schools are down that roadway. And really did help revitalize the business and slow traffic down. I'm sure you guys all know that a lot of these bulb outs, islands, etc., when the road is more narrow, you have this natural traffic calming effect. Obstacles over time. So I talked about, again, engaging stakeholders. So besides utilities, how about the businesses? Of course, businesses, residents, really, really important to make sure that these businesses throughout this entire project had access to them from some way, right? So when we're taking off a whole block, as you can see in the area here, we have to be able to route traffic. And again, make sure these businesses, the one you're looking at with the red roof on the upper right-hand corner is a doctor's office. So making sure that people can get there for their appointments. And also sequencing. So they actually had to make sure they're trying to do it so that people could get to the beach during spring break. It ended up, unfortunately, that they did this during spring break at the end of the beach, by the beach here, but made sure that there were, barricades, safety was of utmost concern, of course, and that people could still get to the businesses and people knew the businesses were open. You can see the same thing with the police officer directing traffic for school. Overcoming obstacles like layers and layers and layers of compacted soil and road base and everything that, over years had just been piled on over the top. Any underground utilities they had to then work around. That was another big thing. 2 hurricanes during construction. So trying to make sure things are protected, it's very hard, right? When you have a hurricane come in and you're doing construction that's a year long, we can't take a stop for 6 months for hurricane season. So then, kind of coming out and cleaning up, but trying to protect things as best you can during construction. So as far as lessons learned, so our rain gardens had curb cuts, making sure that when you're using those curb cuts that you have some kind of stone at the end of that so it doesn't wash everything away. The mulch, as you can see, the first mulch that was put in was easily lifted out by rain events and put onto the sidewalk. So after the fact, went to having pine straw instead.
I could go ahead and do my presentation. Well,
Yeah, I was gonna say, it looks like Jessica may have cut out there. So for now, we can pass it on over to Claire Lewis from Florida Friendly Landscaping.
sure. Okay. Well, hello, and thank you all for being here. I'm happy to be talking about some planting considerations for green stormwater infrastructure. I'm going to give just a little wrap up of things that we've talked about throughout this series. And the first one is the benefits of plants. Plants have just so many benefits in these systems. They filter and uptake nutrients. They increase groundwater recharge through their roots. They reduce erosion, and they provide for wildlife habitat and reduce the urban heat island effect. And on this image, I'd like you to kind of take notice of we're experiencing quite a bit of erosion here on this bank. Where there's no planting. But when you look back here in the corner where there are plants, you can see that the bank is much more stabilized and secure. So that's, one of the benefits of plants in this system. Also want to talk about some planting considerations. And the first one is the size of the plant. We want to make sure that they don't outgrow their location. So we really need to look at both the height and the width that the plant is at their mature size. I think we often see bunch grasses and ornamental grasses planted too close to the sidewalk, and they will interfere with pedestrian circulation if the size is not taken into consideration. Sight lines are also very important. You want to make sure that you don't block important views or block views of desirable features. The aesthetics of the site is something else you want to keep in mind. You want to use a diverse plant palette that has a variety of colors, shapes, and textures. And then in the density of these systems, you want to really plant maybe a little more densely than what you would normally plant to keep up with the weed competition. Fluctuating water levels is also another thing to keep in mind, and it's really the primary concern in a lot of these GSI systems, where the plants need to be able to tolerate both, dry systems and maybe a little more, moist environments. Plant sourcing, this can sometimes be a challenge as well, but I have some great resources that I'll share with you at the end of this talk. Drilling down a little bit on planting considerations is right plant, right place, and it is the cornerstone of a successful landscape. You need to consider how tall and wide a plant is at maturity. You also need to consider how much sun or shade that plant needs, and whether they need well-drained soil or they can tolerate a moist environment, as I said earlier. I think on this image, these plants might be planted a little too close to the sidewalk as well, because I know saw palmetto gets quite large. So that might be, a demonstration of something you'd want to move back a little bit. This next slide is on plant spacing. And it's important to plant for full coverage so that the weed pressure is reduced. This diagram shows the triangular spacing at 3 feet on center. This is the spacing that you would use for a shrub that at maturity grows to 3 feet wide. Planting too close together can cause fungus and disease problems, where planting too far apart can increase that weed pressure. And then we have some resources available to help you select the right plant for the right place. So as Dr. Bean mentioned, we have the GSI plant selection guide. And in that guide, we note things like where the plant should be located. So in the planting zone, you'll see that Coreopsis should be on the bank slope. The plant spacing, 6 to 12 inches apart. Also, what types of GSI systems this is a good plant for, we have listed in this document. So you'll see that here. Then all the growing requirements are located in this section, where we have the sun requirements, the height and width, things like that, what type of soil it likes. And then we're trying to develop for each plant, each individual plant, a maintenance guideline. So we have some maintenance information where that is available. And next, after the plants are in the ground, as I think Dr. Bean has been saying all along, we really need to mulch. It inhibits that weed growth. It keeps the roots cool in the summer and warm in the winter, and it reduces the evaporation. So as Jessica just showed you, the pine bark often floats away. So we recommend the triple shredded hardwood mulch. And pine straw would be the next in line after that, triple shredded hardwood. In areas that have a lot of flow or prone to erosion, we would use rock in those areas. And then as the plants grow in and mature, then less mulch will need to be added. But keep a layer of mulch until those plants are full grown. And then irrigation, we really only want to irrigate to establishment only. So, right plant, right place really helps with that, making sure the plants will thrive with very little irrigation. And then this is maybe, a typical way that you would see that implemented is through these irrigation trucks. Site preparation. We want to minimize that lot clearing and add tree barricades, get the biggest barricade that you can all the way out to that drip line. You want to stabilize the slopes. The slope shouldn't be 4:1 or greater. You want to remove invasives and undesirable species, and here's a select few of those. And when you remove those, you want to take out the roots too, and that will really help reduce the amount of maintenance later on down the line. And do a soil test is a great thing to do, and amend that soil if needed. And then for these systems, it's really important to check that percolation rate in the beginning. Next is plant installation. You want to install, as a general rule, you want to install perennials and grasses during the peak season, which is in the mid to late summer. This will allow enough time for their root systems to become established before they go dormant in the late fall. Trees and shrubs should be planted in the spring when there's adequate rainfall to help develop strong roots and leafy growth. And then you want to water in these new plantings about every 2 to 4 days for establishment. And this can take anywhere from like 6 to 12 months to establish. It will vary by certainly what your weather conditions are and your location. But in keeping in mind that too much water can cause ground covers to develop root problems. So it's a delicate balance between getting them established and not overwatering them. And then we want to keep in mind that routine maintenance is needed. These aren't maintenance-free kind of systems. You do have to go in there and take care of them. And then I think a great tip is to design these systems with clusters of like plants together. So that will make it easier for the maintenance personnel to be able to identify which plants are meant to be there and which ones are growing or volunteering on their own. And we often see some plants outcompete other plants, and that just is a natural occurrence. And that may be okay in some systems where you want a more natural look. And then other, maybe more urban systems where you may want to ensure plant diversity, or you may want to ensure that the design intent and aesthetic is maintained. So in those systems, you might prune back the ones that are really excelling to keep your design intent complete. And we've developed, Dr. Bean showed an image of this earlier. This is the GSI Maintenance and Planting Manual. We developed this certification program. There's a need for this as many cities and counties are installing large green stormwater infrastructure projects. And unfortunately, we've seen some of these systems fail as a result of improper maintenance. So included in this program is a GSI maintenance manual, a plant selection tool, a maintenance checklist for each of the GSI systems that's in both a PDF and an online version. And the training itself is a hybrid training where you would take the online modules and then come to an in-person regional training event. And this information can all be found on the Green Stormwater Infrastructure webpage. I did put that link in the chat earlier, but you'll see there's online and PDF checklists. There's a link to the DEP Green Stormwater Infrastructure website. There's a video series, and then also this webinar series is there as well. These are the plant resource information that I was talking about. We have the FFL plant guide that's also available. This is a free app. that you can look for plants on. We also have several other apps that are available. And then the Florida Association of Native Nurseries is a great way to locate some of these native plants that we often recommend for the green stormwater infrastructure. You would put in the type of plant that you're looking for, and then it would show you the different nurseries that have it available in stock, and also how to reach them and find out when you can go pick up those plants. And with that, that is my recap. So I will go ahead and stop sharing my screen and open the webinar up for questions.
Awesome. Thanks, Claire. Before we jump into the questions, Jessica had a bit of a technical difficulty, so she's going to pull her presentation and back up and finish her last few slides.
Super.
All right, so we are here, which I think Claire covered well, and Evan already covered really well about right plant in the right place. There was a lot of that going on in Cocoa Beach, and I know it's still, you know, needing replanting and stuff. So just making sure as well when you do one of these projects that you are going to budget accurately, making sure you get quotes of, you know, what it's going to be like to actually maintain these if you cannot do it in-house, because I can tell you it takes a lot of manpower, a lot of man hours to take care of these gardens, and you know, especially if you're doing a replanting, remulching, etc. So I would definitely get some estimates for contractors to come in and do that for you, so that way you know what to put in your budget. I will also say, again, going to, you know, away from you're going from nothing. Obviously, you can see what was here initially did not do very well, whereas we planted some Indian blanket flower, and amazing. And knowing which contractors that you're using, and knowing that they understand what natives and Florida-friendly species look like versus a weed. So they will be kind of hand-picking in there, and if they don't, it can end up looking like you see in the lower right. As far as pavers, you know, again, knowing the life cycle, knowing when things need to be cleaned out and redone. For these types of pervious pavers, there is an aggregate in between those. That sand, the aggregate is actually meant to collect different things that go in there. But if there's curb cuts that are really close, what we learned is that organics can sometimes then get out of those curb cuts, and then it kind of expedites the clogging of these pavers. So thinking about placement of those curb cuts, and also, again, that plan for maintenance with those pavers, making sure you have that built into the budget, and understand what that entails. I won't go into this because Claire just did, but I do also just want to plug the importance of pre-treatment. So as you can see here, this is one of the pre-treatment devices that leads into the rain gardens, and you can see all the different things that it's catching. So that is another thing that the crew goes out, they use a vac truck, they clean that out. But I just wanted to show you that, to actually see that that is capturing. So pre-treatment is really important to actually then centralize that maintenance and keep everything longer lasting inside that garden. And just to give some recognition to the different partners, different awards, so that we can give recognition to them. And I'm going to hand it back over to Nathan because I know we're getting closer to our time. So thank you, guys.
Awesome. Thank you, Jessica. Before we get started with our Q&A, I'm going to just briefly recap some of the funding opportunities from the non-point source management program here at DEP. And while I do so, I would encourage everyone to put into the chat box, or I'm sorry, not the chat box, the question and answer box, any questions that you might have regarding concepts that we covered today. And, you know, even if it's not something that we covered today, we have a lot of great experts on our panel here. So if you have any questions regarding GSI in general, you got the right people in the room or on the call that can probably give you an answer or guide you towards your answer. So with that, I'll share my screen really quickly. All right. So as I mentioned, I'm going to cover some funding opportunities from the non-point source program here at DEP. And some of you may be familiar with them. So the first one I'm going to start off with is our 319H grant, which is from the United States Environmental Protection Agency, EPA. So with this grant, we're very eager to fund green stormwater infrastructure projects. With that said, we can also fund traditional projects. Just to go over some of the grant requirements, and eligibility. Construction, education, and monitoring are all eligible for funding under this grant. One thing to keep in mind is that there is a 40% match requirement, and one caveat with that requirement is that you can use state grants or loans as that match. So you could potentially get one of our SWAG grants, which I'll cover in my next slide, or you could get a loan from our SRF program, our State Revolving Fund program, and those can be leveraged as match towards a 319H project. Another thing to consider is it may take a bit more time to receive the award when compared to some of our other grants. So a project doesn't necessarily have to be completely shovel ready. There is a bit of a delay between the time that we select projects for funding and then that the project is actually awarded the funding. And just another thing to keep in mind, planning and design may be eligible for match. So as I mentioned, in addition to green stormwater infrastructure, we're also able to fund water quality improvement projects, groundwater protection projects, water quality restoration projects, stormwater BMPs, non-point source education projects, and septic to sewer projects. So now I'll cover our state grant, which is our State Water Quality Assistance Grant, which we call our SWAG grant. And I mentioned in my slide before, 319, doesn't necessarily need to be shovel ready at the time of applying. For the SWAG grant, we're typically looking for shovel-ready projects. There is no required match for the SWAG grant. However, including match in your proposal can certainly help when it comes time for project selection. And the same with regards to monitoring. Monitoring is not a requirement with SWAG like it is for 319. However, we're very eager to obtain data on our BMPs and understand how they're performing in the world. So having monitoring on your proposal can definitely help with project selection because we're very eager to obtain data on our projects. Again, just keep in mind, it is a much faster application to award date than the 319 project, or than the 319H grant, I'm sorry. And as I mentioned, with the 319H grant, we're very eager to fund GSI. Same goes with our SWAG grant. Very eager to fund green stormwater infrastructure projects. However, we can also fund traditional gray infrastructure projects. So that can include water quality improvement projects, groundwater protection projects, water quality restoration projects, stormwater BMPs, as well as reuse projects. So now I'll cover quickly how to submit a proposal. In order to apply for this funding, a grantee must be a local government, a special district, or a public university. We use one proposal form for both of these grants, so you can apply for both at once. You can attempt to leverage one against the other, like I mentioned, maybe using some SWAG funding to leverage against 319H grant. But it is one proposal document for both grants. And you can use the Protecting Florida Together portal to view grants that are available, not just from the non-point source program, but that is agency-wide. So across the whole Department of Environmental Protection, all of the grants will be listed on Protecting Florida Together. And I have a link to that at the end of my presentation here. So if you would like to get more info on these non-point grants, you can contact Connie Becker, and Connie can provide you with a copy of the proposal document. Connie is the non-point grants coordinator. Typically, non-point will review proposals once during the fall and once during the spring of each year. And there's not an exact date that occurs. It kind of depends on when we receive our awards and different timelines. So you can keep an eye out in the fall and spring of each year. And the best way to stay up to date with that is to subscribe to the division's email list, which I can drop in the chat after this. And just to keep in mind that if funding is available, occasionally it will be awarded out of cycle. Sometimes projects don't utilize all their funding or they don't end up working out, and then there is some funding left over. So you are able to submit a proposal at any time, and if there is funding available out of cycle, we'll do our best to award it, and if not, it will be considered in the next proposal review. So if you're considering a grant application, you can contact Connie Becker to discuss eligible grant components, funding availability, and match requirements, and really any other questions that you might have related to these grant opportunities. And again, just a reminder, we review twice per year, once during fall, once during spring. And here's Connie's contact. So Connie L. Becker at floridadep.gov. Again, that's the non-point source grants coordinator. And then at the bottom of this slide, you can also see a link to the Protecting Florida Together website that I mentioned. And there you can find information on grants department-wide. So not just non-point, all of the grants from the Division of Water Restoration and Assistance. So our water quality grant, our springs grant, information on those can be found on Protecting Florida Together. And it does change as grants become available and close, different project solicitations open and close. But again, not just the Division of Water Restoration Assistance, department-wide, you can find information there. And I'll also drop that link in the chat as well. And with that, we'll move into our question and answer. So I'll go ahead and stop sharing my screen. Alrighty. So I'd like to invite our presenters to join us again, and we can get started right away. And Naomi dropped this question into the chat while Dr. Bean was talking about the permeable paver system. So Naomi asks, what is your feedback on using the paver system versus a plastic grid for parking that allows grass to grow and be mowed? I'm not sure what the technical name is for that. And I'll leave that up to our panel to address.
Sure, that's a great question. These are typically referred to as grid pavers or plastic, as opposed to concrete grid pavers or turf reinforcing grid pavers. And they typically are filled with like they might be installed over a stone base, similar to other types of permeable pavements. And they have a plastic grid, and then it's filled with sand and maybe some sod or grass has grown into it. One of the main aspects there is, you still have to have conditions that promote the support of vegetation in those types of installations if you have a grassed system. And so when we think about parking, the main aspect there is making sure that it's not going to be parked on every day, because then you're going to be blocking sunlight. There's also what the pavers do is they sort of transfer the loading from the tires to the stone below without compacting the soil. So that's a good thing. But if we don't have a regular, if we have a regular occupancy in that parking area, that's probably not the best use for it, because the vegetation won't get enough sunlight and it just won't thrive. The best applications for these are going to be applications where you have sort of predictable or reliable kind of low frequency traffic. Think houses of worship, think sports complexes that might have traffic once a week or have vehicles parked once a week. Things sort of like that. So that's sort of the main trade-offs between those types of systems there. And I think in the park aspect here with Alachua County, they can't really predict when they will have traffic there. It's sort of open all the time and sort of applicable, or it could be parking in any of those spots at any time.
Awesome. Thanks, Dr. Bean. Did any of our other panelists have anything to add there? Okay, great. And we just had another question come in. Cynthia asked, please review who is eligible to apply for SWAG grants. So that would be local governments, special districts, and public universities in the state of Florida, as well as nonprofits, I should mention as well. I'm sorry. And then I don't see any other questions, but we did have a few comments that came in. So I think we can kind of rephrase those as questions and see what our panel thinks about them. So when Dr. Bean was discussing some of the bioswales in the Innovation Park project, Richard mentioned that it looks like it needs a different grate, maybe arched or angled to minimize clogging. So just curious if Dr. Bean had any thoughts on that.
No, that's a great suggestion, because when you have sort of an angled or at an angle like that, you don't have it just kind of a flat surface that everything kind of gets deposited on top of it. That debris can kind of get blocked at the bottom. The water level goes up a little bit, but then it's open and it's clear, so it's able to kind of flow past it. So yeah, it's definitely a good thought and good consideration. Hindsight being 2020. It would have been a good design feature to implement rather than maybe a flat surface. And that's something to think about as far as like designing for maintenance and designing for these types of issues, if you think you're going to have sort of a lot of material being generated or the potential for clogging, might be good to have sort of a sloped or arched grate in that situation.
Awesome. Thanks, Dr. Beam. And then we just had a couple more roll in, so we'll address those. Cynthia asked, what incentives are there to encourage private developers to use these practices in new construction?
Well, to be honest, there's a cost element. And that is an incentive. There is, these types of practices can be less costly than your conventional development. You can spend excess money on conventional development. You can also spend excess money on green stormwater infrastructure. Putting permeable pavements everywhere is not going to be necessarily the most effective and cost-effective approach. But using it selectively in certain projects, in certain areas where that's the area that you have, and if it offsets the cost of land, that's a good place to put it. Swales are much cheaper than stormwater pipes. So if you can put in swales and basically construct them and install them and get that permit and it's allowed, that's going to be cheaper than putting in stormwater pipes. We present on some case studies that where they've essentially reduced or eliminated lengths of stormwater pipe, or reduced the size of stormwater pipe through implementing green stormwater infrastructure practices that are offset to that requirement.
Awesome. Thanks, Dr. Bean. And I see you might be reading that one, but Susan asked if we can. Susan asked if we can elaborate on soil pre-treatment in large areas, and I saw Jessica did start typing a response. So if either of y'all would like to address that.
Sure. Yeah, I was typing, so I didn't forget it. So for the other question that was about the flat grate, yeah, we could definitely do domed grates, and even some that have like a geotextile bag on the inside. So even as things like the mulch maybe floats up and crests up, it keeps most of it out, but then whatever does get in, now there's like this kind of secret bag on the inside that catches things. And again, it's one of those like centralizing maintenance. So we can start with the pre-treatment box to begin with, and then we can, on the outflow, do the same kind of thing, right? So catching things on the inside and then catching things before they go out. So again, centralizing maintenance in both ways. Oh, Nathan, you're muted.
Nathan, you're muted.
Sorry about that. And then did anyone have any thoughts on soil pre-treatment in large areas?
I touched on that. Jessica, did you touch on that?
I guess, I mean, any of the catch basin boxes that are specific for pre-treatment, not just a standard catch basin. There are several different types out there for sure. You can definitely reach out if you want more information on those as well, Susan.
Awesome. Thanks, Jessica. And then looks like maybe our last one is, again, another comment, but I think it's something that we can kind of pose to the group and see what they think. Where Kathleen mentioned that they agree that larger plantings would be more sustainable, and that more variety of plantings, maybe more ground cover versus mulch, and to plant them outside of the rainy season. So maybe just some planting thoughts to ponder.
I definitely think the larger plants are going to be more easily identified as being, meant to be in the system and to be cared for and watered and taken care of like that. And I can see how during the rainy season it might be kind of tough on the plants, on the new plantings. It's a fine line between we need that extra rain as to help them establish, and then not too much to wash them out. So
All right, awesome. Thanks, Claire. Well, with that, I would like to just remind everyone again that for additional grant opportunities, so please check out the Protecting Florida Together, as well as the non-point source Green Stormwater Infrastructure website. For a variety of resources, please check out that non-point source Green Stormwater Infrastructure website. You can find a lot of the topics that we've covered throughout this series and much more there. And that's a website that we're constantly working on adding to and evolving. So if you keep checking back over time, we're hoping that you'll find new stuff and things that can really help y'all with your implementation of green stormwater infrastructure projects. I'd also like to send a special thank you to all the folks that have joined us throughout the 9 webinars that we put on. It's really been a privilege for us to be able to pass this important information on to you. And we're really eager and excited to hopefully see some new proposals come in to fund green stormwater infrastructure projects, and just to get to go out into the world and see all these great projects that y'all are putting into the ground. And I'd also like to thank all of our presenters. We've had a lot of experts join us throughout this journey of this series, and I think everyone's brought, their unique perspective, knowledge, and understanding of these systems. And it's been really, I feel very grateful that I've gotten to learn from y'all, and we really appreciate you sharing the information that you've worked hard to learn about, and getting it out there into the world for folks to utilize. So we really appreciate that. And again, please be sure to check out all of our websites, being Protecting Florida Together, gsi.floridadep.gov, floridafriendlylandscaping.com, you name it. There's great information on all of them. So with that, I'd like to send one big thank you to everyone, and I hope everyone has a great day.
Bye.